There is a number that most people have never heard, and it will one day determine whether human beings live or die on another planet. 38 minutes. Not 38 years, not 38 days, 38 minutes. That is the maximum length of time at the worst possible orbital alignment between Earth and Mars, during which every signal sent between the two planets travels through space at the speed of light and still takes 19 minutes to arrive in each direction. 38 minutes of total silence. 38 minutes during which an astronaut on the Martian surface could scream for help, and no one on Earth would hear it for nearly half an hour. And even then, any response would take another 19 minutes to return. In the history of human spaceflight, we have never truly been alone. Every astronaut who has left this planet has remained tethered to Earth by an invisible thread of radio waves. The Apollo crews on the Moon experienced a delay of roughly 1.3 seconds, barely noticeable, almost conversational. The astronauts aboard the International Space Station are so close that their communications are essentially real-time. Even the robotic probes we have sent to the outer solar system, Voyager 1, now more than 23 billion kilometers away, still whisper back to us. And we can still whisper to them, even if those whispers take more than 20 hours to cross the void. But Mars is different. Mars does not stay still. Mars moves, and as it moves around the Sun in its own orbit, the distance between our two planets changes constantly and dramatically. At its closest approach, a configuration called opposition, Mars can come within about 54 million kilometers of Earth. At that distance, a radio signal traveling at the speed of light takes approximately 3 minutes to arrive. That is still significant for a real-time conversation, but it is manageable. Mission controllers can relay information, astronauts can send a distress call and receive an acknowledgement within 6 minutes. But Mars does not stay at opposition. It keeps moving, and so does Earth. Their orbits are not synchronized. Earth swings around the Sun in 365 days. Mars takes 687. The geometry between them is constantly shifting, and approximately every 26 months they reach a point on opposite sides of the Sun and a configuration called conjunction, where the distance between them stretches to over 400 million kilometers. At that distance, a signal moving at the speed of light takes approximately 22 minutes to arrive. The round-trip communication delay reaches 44 minutes. The 38-minute figure sits just below that maximum. It represents not the worst-case scenario, but rather the extended operational window, the kind of delay that a crewed Mars mission will live inside for months at a stretch during the middle and outer portions of its mission timeline. For practical planning purposes, 38 minutes is the number that mission designers use when modeling the communications blackout problem. It is the number that keeps the engineers awake at night. It is the number that will define, more than any other single factor, what it actually feels like to be a human being on Mars, and here is what that feeling will be. You wake up on Mars. It is, let us say, the 14th month of a 24-month surface mission. The Sun is a pale, cold disk in a butterscotch sky. The pressure outside your habitat is less than 1% of Earth's atmospheric pressure. The temperature outside, even in the Martian afternoon, is minus 30 degrees Celsius. Your suit will keep you alive for 8 hours. Your habitat is pressurized to roughly sea-level conditions, and the air inside is processed and recycled. You have water, food, and power, for now. You sit down at your communications terminal and compose a message to the flight surgeon back in Houston. You are worried about a rash that appeared on your left forearm 3 days ago. It does not look infected, but it is spreading slowly, and you want a medical opinion. You send the message at, let us say, 9 o'clock in the morning, Mars local time. You will not receive a response until approximately 9:38. So you go about your morning. You run your diagnostics. You check the power levels on the habitat's solar array. You review the geological samples your rover collected yesterday. You eat breakfast. You think about the rash. And then at 9:38, a message arrives from Houston. The flight surgeon has looked at the photograph you attached. She has a few follow-up questions. She wants to know if the rash is raised or flat, whether it itches, whether it appeared after your last EVA or before. She asks you to send another photograph with different lighting. You answer her questions and send the photograph at 9:45. You will not receive her response until 10:23. This is the rhythm of life on Mars, not a conversation, a correspondence, not a phone call, a series of letters that take 38 minutes to cross the void in each direction. It is, in functional terms, closer to the pace of 19th century communication by ship and post than to anything we experience in the modern world. And while the rash scenario is minor, inconvenient, perhaps anxiety-inducing, but manageable, you can already feel the weight of what this delay means when you scale it up to a genuine emergency. What happens when it is not a rash? What happens when it is a fire? In the history of crewed spaceflight, fire is among the most feared emergencies aboard any spacecraft or habitat. The Apollo 1 fire killed 3 astronauts on the launch pad in 1967 in a matter of seconds. Fire in a pressurized environment where oxygen is carefully controlled and every surface is potentially flammable can spread with terrifying speed. On the International Space Station, fire emergency protocols are immediate and non-negotiable. The crew acts first. They do not wait for instructions from the ground. But on the ISS, the communications delay is measured in fractions of a second. If a crisis unfolds and mission control sees it on their monitors, they can respond almost instantly. The astronauts and the ground are effectively in the same room, operationally speaking. On Mars, a fire starts. The astronaut at the communications terminal notices a smoke alarm. She looks up from her screen and sees a thin haze near the far wall of the habitat. She's already moving, grabbing the extinguisher, activating the emergency suppression system, calling out to her crewmates. She sends a distress signal to Earth as she moves. The signal leaves Mars at the speed of light. It crosses 400 million kilometers of empty space. It arrives at Earth's Deep Space Network antenna 19 minutes later. Mission Control reads the alert. They see the alarm data. They begin formulating a response. They send their reply. Their reply arrives on Mars 19 minutes after that. The fire, in the best-case scenario, started and ended, one way or another, long before Mission Control's first response reached the crew. In that 38-minute window, the astronauts on Mars were completely and utterly alone with their emergency. They could not ask for help in any meaningful, real-time sense. They could only act on their training, their procedures, and each other. This is the window. This is what the 38 minutes actually means in practice. It is not just a communications delay. It is a fundamental redefinition of what it means to be supported, to be connected, and to be in contact with home. And it gets stranger, because the 38-minute delay is not a fixed number. It is not like the 1.3-second moon delay, which was essentially constant throughout the Apollo missions. The Mars delay changes every single day. It grows and shrinks as the two planets orbit the Sun. During the early phases of a Mars mission, or when Earth and Mars are still relatively close, the delay might be only 4 or 5 minutes. The crew can almost have a real conversation with mission control. They can ask a question and receive an answer within 10 minutes. It feels, if not normal, at least workable. But then the planets keep moving, and the delay grows. 5 minutes becomes 8, 8 becomes 12, 12 becomes 16. And then, somewhere around the 8th or 9th month of a surface mission, the delay crosses the threshold of 20 minutes each way, and something subtle but profound changes about the psychological relationship between the crew on Mars and the people on Earth. Because 20 minutes is long enough that mission control cannot realistically guide a crew through any dynamic, fast-moving situation. 20 minutes is long enough that by the time Earth receives a status update from Mars, the situation that status update described has already evolved significantly. 20 minutes is long enough that the astronauts on Mars must be capable of making every critical decision themselves without waiting for approval, without waiting for input, without waiting for anything from home. This is not how NASA has traditionally operated. NASA's mission control culture is, by design, centralized. The astronauts in space are extraordinarily capable, but they are supported by hundreds of specialists on the ground who monitor every system, analyze every reading, and provide a continuous stream of guidance and correction. The Apollo 13 story, the one that has become perhaps the defining narrative of human spaceflight, is precisely a story about mission control saving the crew. Failure is not an option is a phrase that speaks to the ground team, not the astronauts. The ground team keeps the astronauts alive. On Mars for 38 minutes at a time, and effectively, for all practical purposes during any fast-moving crisis, there is no mission control. There is only the crew. The implications of this are so significant that they have already begun reshaping the way space agencies and private companies think about crewed Mars missions. The shift is not merely technical, it is psychological, it is organizational, it is, in a deep sense, philosophical. What kind of people do you send to Mars? Not just physically capable people, not just intellectually brilliant people, but people who can function as a completely self-sufficient unit, making life and death decisions in real time without the safety net of a ground team that can intervene. People who can disagree with mission control and know that, in the moment, they are right and Houston is working with 19-minute-old information. This question, who goes to Mars, has been studied intensively. The psychological profiles that emerge from that research are specific and sometimes surprising. The ideal Mars crew member is not necessarily the most technically brilliant candidate. They are someone who can function under prolonged isolation, under communication latency, under the particular and unusual psychological pressure of knowing that help is nearly 40 minutes away at best. They are someone who can be wrong and correct themselves without spiraling, someone who can disagree with their crewmates without fracturing the group, someone who can miss their family, their home, their planet for 2 years and keep working. The 38-minute window selects for a specific kind of person, and it selects against others. But before we get to the people, we need to understand the physics, because the communications delay is only one part of the 38-minute problem. There is another layer to it, a darker layer, and it concerns not the delay itself, but a specific period during every Mars mission when the delay becomes something worse than merely long. It becomes total. There is a period during the orbital geometry of Earth and Mars lasting approximately 2 weeks and occurring every 26 months, during which Mars passes behind the Sun from Earth's perspective. This is called solar conjunction. During solar conjunction, the Sun itself sits between Earth and Mars, and the plasma of the solar corona disrupts and absorbs radio signals. No communication is possible. Not slow communication, not degraded communication, no communication at all. 2 weeks of complete silence. For a crew on Mars, solar conjunction is not merely an inconvenience, it is a planned operational period during which they must be entirely self-sufficient, operating on pre-loaded instructions and their own judgment, with no ability to send or receive any message from Earth whatsoever. If something goes wrong during solar conjunction, a medical emergency, a habitat failure, a catastrophic equipment breakdown, the crew handles it alone, and Earth will not know what happened until the blackout ends. The 38-minute window, then, is not just about the daily rhythm of delayed communication. It is the prelude to something more extreme. It is the dress rehearsal for conjunction. It is the universe testing whether these human beings can function without the planet they came from. And here is the thing that sits beneath all of this, the thing that makes it not just a technical problem, but an existential one. Mars is not just far away. Mars is far away in a direction that is constantly changing. There is no fixed distance to Mars the way there is a fixed distance to the Moon. The number shifts every day, in both directions, over a range that spans an order of magnitude. And the human beings who go to Mars will feel that shift, not in a technical, abstract way, but in a visceral, daily, lived way. They will feel the delay growing. They will feel the window closing. They will feel the moment, somewhere around month 8 or 9, when mission control stops being a real-time resource and becomes something more like a very attentive, very supportive, very delayed pen pal. And they will have to decide, each of them individually and as a crew collectively, whether that is enough, whether Earth's voice, arriving 19 minutes late, carrying warmth and knowledge and care, but unable to reach them in any moment that actually counts, whether that is enough to sustain them, whether they can do what no human being has ever done, live for 2 years in a place so remote that the entire infrastructure of human civilization, are all the doctors, all the engineers, all the mission controllers, all the loved ones, is separated from them, not just by distance, but by time. Not by the time it takes to travel, by the time it takes for light itself to cross the gap. The 38-minute window is not a number on a mission planning chart. It is a psychological frontier. And the people who cross it, the ones who sit on the Martian surface listening to a radio that delivers news from home nearly 40 minutes after it was spoken, those people will have crossed into a kind of solitude that no human being in the history of our species has ever experienced. They will be alone in a way that is new to us, and we have to ask, are we ready to send them there? We have been asking that question in various forms for decades, but we have never had to ask it with this kind of urgency, because for the first time in human history, the technology to actually put people on Mars is within reach. Not within reach in the sense of a vague ambition, within reach in the sense of engineering schedules, budget allocations, and rocket test programs. The companies and agencies that would carry out a crewed Mars mission are not dreaming. They are building. And as they build, the 38-minute problem is moving from the realm of theoretical concern into the realm of active operational planning. Engineers are designing communication relay satellites that will orbit Mars and extend the window during solar conjunction. Psychologists are developing protocols to help crews manage the transition from high contact to low contact phases of a mission. Mission planners are restructuring the traditional NASA command hierarchy to accommodate the reality that, once a crew is on Mars, they are the commanders of their own mission. The window is being planned for, but it cannot be eliminated. The speed of light is not a design parameter that can be optimized away. It is physics, and physics does not negotiate. So the 38 minutes will exist. They will always exist for as long as human beings travel between Earth and Mars. Every crew that lands on that planet will experience the delay growing day by day as the orbits shift. Every crew will have their first conjunction. Every crew will spend 2 weeks in total silence. And before any of that begins, before the first crew even lands, there is a countdown. A specific, calculable sequence of events that begins with launch and ends, not with touchdown on Mars, but with something more subtle and more profound. It ends with the moment when the crew crosses the threshold. The moment when the round-trip communication delay exceeds the time it would take a crisis to resolve itself. The moment when Mission Control acknowledges, formally and in their own planning documents, that they are no longer in operational command of the mission. The moment when, for the first time in the history of human spaceflight, the people on the ground look at their screens and realize that whatever happens next, they will find out about it long after it is already over. That moment is coming. Depending on which organization achieves the first crewed Mars landing and when, that moment could arrive within this decade. It could arrive within the lifetimes of most people alive today. It is coming, and the 38-minute window is where it begins. In the next section, we are going to trace the countdown from Earth to that threshold, the specific phases of a Mars mission from launch to landing to the first day on the Martian surface, during which the communications delay transforms from a minor inconvenience into the defining reality of human existence on another world. We will look at what those early, relatively close phases feel like. The days when the delay is still only a few minutes, when Earth still feels almost reachable, and we will begin to track the slow, inexorable growth of the gap. Because the 38 minutes does not arrive all at once. It builds, day by day, kilometre by kilometre. It grows like a shadow lengthening across the floor of a room as the sun moves west. And by the time the crew realizes how long the shadow has become, they are already standing in it. The journey to Mars begins, in a sense, long before the rocket leaves the ground. It begins in the mathematics of orbital mechanics, a branch of physics that is, at its core, a science of timing. You cannot simply point a rocket at Mars and fly there in a straight line. Mars is not where you are pointing when you launch. Mars is where it will be, months from now, when your spacecraft finally arrives after tracing a long, curving arc through the inner solar system. You are not flying to Mars. You are flying to where Mars will be. And this distinction, the fact that the destination is a moving target whose position must be calculated months or years in advance, is the first and most fundamental lesson of interplanetary travel. The window in which a Mars mission can be launched is narrow. It opens approximately every 26 months when the orbital geometry between Earth and Mars lines up favorably enough that the energy cost of the journey is manageable. Miss the window, and you wait more than 2 years for the next one. There are no shortcuts. The universe does not offer alternative routes. You fly the trajectory that the physics allows, or you do not fly at all. The most common trajectory studied for crewed Mars missions is called a Hohmann transfer, a half-ellipse that swings out from Earth's orbit and intersects Mars's orbit at the far end. The transit time on this trajectory is approximately 7 months. 7 months of travel before the crew even arrives at Mars, during which they are already accumulating radiation exposure, already experiencing the physiological effects of microgravity, already beginning the psychological compression that comes from living in a spacecraft roughly the size of a large recreational vehicle with 4 to 6 other people. And during those 7 months of transit, the communications delay is already growing. On launch day, if the mission departs during an optimal window, Earth and Mars are separated by somewhere between 100 and 200 million kilometers, depending on the specific geometry of that particular launch window. At that distance, the one-way signal travel time is between 5 and 11 minutes. Inconvenient, but far from catastrophic. Mission control can still function in something like its traditional role. Status updates arrive within 20 minutes round trip. Questions can be answered, problems can be diagnosed, decisions can be consulted on, all within a time frame that still resembles something like a conversation, albeit a slow and awkward one. The crew launches. The rocket performs its trans-Mars injection burn, sending the spacecraft out of Earth orbit and onto its long, curving path toward the red planet. Earth begins to shrink. The home planet, which fills the window of the spacecraft with blue light on launch day, diminishes over the following days and weeks into something smaller. Within a week of departure, Earth is a bright blue-white dot. Distinctly smaller than the Moon appeared from the lunar surface. Within a month, it is a pale blue point of light, indistinguishable at first glance from a bright star. The crew knows this is happening. They have been trained for it. They understand the optics and the psychology. But training and knowledge do not fully insulate against the lived experience of watching your world shrink into a star. Meanwhile, the delay grows. In the first weeks after launch, the delay increases slowly. Earth and Mars are still not dramatically far apart. The spacecraft has not yet traveled far enough to significantly change the geometry. The crew can still send a message home and receive a response within 20 or 30 minutes. It feels, if not normal, at least workable. Mission control is still monitoring every system. The flight surgeons are still reading every biometric. The trajectory analysts are still tracking the spacecraft's position to within meters. By the end of the first month, the delay has grown to perhaps 15 minutes each way. Mission control can no longer realistically guide the crew through any fast-moving situation, but they can still provide detailed technical support on issues that develop gradually. A slowly worsening equipment fault, a gradual change in a crew member's health metrics, a navigational calculation that needs verification. These can still be handled collaboratively, with Earth and crew trading information and analysis across the growing gap. But the gap keeps growing. The second month of transit sees the delay push past 20 minutes each way. And here is where something changes. Not in the physics, not in the equipment, but in the crew's psychology. There is a term used in the psychology of isolation research, perceived locus of control. It refers to a person's sense of whether they are the primary agent in their own situation, whether their decisions and actions are the ones that matter, or whether they feel that control resides with some external authority. In normal operational spaceflight, astronauts on the ISS have a relatively low perceived locus of control, at least in terms of major decisions. Mission Control is watching. Mission Control is advising. Mission Control, in extremis, is directing. The astronauts execute. They are extraordinarily capable executors, but the chain of command runs through Houston, and everyone understands this. On a Mars mission, as the delay crosses 20 minutes and keeps climbing, the perceived locus of control undergoes a fundamental shift. The crew begins to feel, and then to functionally enact, their own authority. This is not insubordination, it is physics. If a situation develops on the spacecraft and Mission Control cannot receive news of it and respond within the time frame in which that situation evolves, then Mission Control is not, in any operational sense, in command of that situation. The crew is. Mission planners have known this for decades. The design of crewed Mars mission operations has always accounted for it, at least on paper. Crews will be given greater decision-making authority than any previous crewed mission. Standard operating procedures will be preloaded, pre-approved, and designed to be executable without real-time ground approval. Commanders will have the authority and the responsibility to act unilaterally in any situation that does not allow time for a ground consultation. But knowing this in principle is different from designing for it in practice, and designing for it in practice is different from living it. And the crews who will travel to Mars will need to do all three. There is a particular kind of meeting that takes place during the transit phase of a Mars mission, at least in the simulations and analog studies that have been run on Earth to model it. It is a meeting that has no formal name, but that always occurs in some form, somewhere, around the second or third month of the journey. The crew gathers, and someone, sometimes the commander, sometimes the medical officer, sometimes just whoever happens to raise it first, says something like, "We are mostly on our own now." Not entirely. Not yet. Earth is still reachable. Questions can still be asked and answered. The flight surgeon is still reviewing the medical data. Mission Control is still there in the sense that they exist, that they care, that they are doing everything they can. But the crew has crossed some internal threshold, not the mathematical one, not the 20-minute mark or the 30-minute mark, but a psychological one. They have felt, collectively, the weight of their distance. They have understood, in their bodies, and not just their minds, that whatever happens in the next 20 months, they are going to be the ones who handle it. This meeting, this informal, unceremonious moment of collective acknowledgement is, in the view of many Mars mission psychologists, one of the most critical events of the entire mission. How it goes matters enormously. A crew that handles it well, that acknowledges the reality of their situation, that expresses the anxiety it naturally produces, that then redirects that energy into trust in each other and confidence in their preparation, is a crew that will likely hold together. A crew that avoids the conversation, that maintains a performed certainty that they are fine, that suppresses the emotional weight of what they are confronting. That crew is storing up psychological debt that will compound over the coming months. The 38-minute window is not just a communications engineering problem, it is a human problem. And the human problem begins here, in the transit, months before the crew ever sets foot on Martian soil. But let us return to the physics, because the physics is doing something important while the psychology unfolds. As the spacecraft travels outward on its Hohmann arc, two things are happening simultaneously. Earth is falling behind, moving around the Sun on its faster inner orbit, beginning to swing away from the spacecraft's trajectory, and Mars is approaching, not directly, but from the geometry of both worlds, converging at the far end of the transfer arc. The communications delay, which is determined by the straight-line distance between Earth and the spacecraft, does not grow linearly. It grows in a complex curve that depends on the specific orbital positions of Earth and Mars, the spacecraft's position along its trajectory, and the geometry of the Sun's position relative to all three. What this means in practice is that the delay does not grow smoothly. There are periods of relatively stable delay, and there are periods of rapid change. And the most disorienting of these periods occurs in the final weeks of the transit, as the spacecraft is closing in on Mars, and the delay from Earth is near its peak for that phase of the mission. For a crew approaching Mars for the first time, those final weeks are among the most psychologically compressed of the entire journey. They are performing the detailed preparation for landing, running checklists, training on landing simulations, reviewing surface operations protocols. They are physically adjusting to the prospect of gravity again after 7 months of weightlessness. They are emotionally processing the magnitude of what they are about to do. They are, in many cases, dealing with the accumulated fatigue and interpersonal friction of 7 months in a confined space with the same small group of people. And they are doing all of this while the communications delay with Earth is near its maximum for the transit phase, typically somewhere between 15 and 20 minutes each way, and while their attention is necessarily focused on Mars, on the landing, on the mission ahead, rather than on home. Mission planners refer to this period as the communications isolation peak of the transit phase. It is the point at which the crew is most psychologically stressed, most operationally busy, and most communications constrained simultaneously. It is the worst possible time to have a serious disagreement with mission control. It is also, unfortunately, one of the most common times for exactly such a disagreement to occur. Because here is a reality that the history of both crewed and robotic space missions has confirmed repeatedly. The people on the ground and the people in space frequently disagree about the risk tolerance appropriate for any given decision. Mission control tends toward caution. Crews embedded in the immediate physical reality of their situation sometimes assess risk differently. On the ISS, this tension is managed in real time, with ongoing dialogue and the ability to escalate or de-escalate based on new information. On a Mars transit, with a 20-minute round-trip delay, the tension becomes structural. A crew nearing Mars can send a message to mission control saying, "We think the landing should proceed as planned. The conditions look acceptable." Mission control can respond 20 minutes later, saying, "We want you to hold for another orbit. The dust storm data is inconclusive." The crew can respond 20 minutes after that, saying, "We have reviewed the dust storm data, and we believe the risk is within acceptable parameters." By now, 40 minutes have passed. The orbital mechanics may have already moved the spacecraft past the optimal landing window. The crew commander may have already made the call. This scenario, crews making time-sensitive decisions before ground approval arrives, is not a failure of mission planning. It is the expected operational reality of a Mars mission. It has been acknowledged by every serious mission architecture study for the past 20 years. The question is not whether it will happen, but how to structure the mission so that when it happens, the crew is making their independent decisions with the best possible training, the best possible procedures, and the best possible mutual trust with the ground team. The trust question is, in many ways, the deepest one, because the 38-minute window does not just test the crew's capabilities, it tests the relationship between the crew and the people on Earth who sent them there. Consider what that relationship actually entails at the moment of a crewed Mars landing. The crew is about to attempt the most dangerous landing in the history of human spaceflight. Mars's atmosphere is thin enough that it provides less aerodynamic braking than Earth's, but thick enough that the spacecraft cannot simply rocket down to the surface. The entry, descent, and landing sequence, EDL, is a precisely choreographed series of events that must occur correctly, in sequence, over a period of approximately 7 minutes. Engineers call it the 7 minutes of terror. The entire sequence from atmospheric entry to touchdown is too fast for any real-time ground intervention. Whatever happens in those 7 minutes, the crew is completely alone. Mission Control will watch their screens. They will see the spacecraft's telemetry data. 14 to 20 minutes after each second of the descent has already occurred. By the time they see the entry burn, the spacecraft has already been on the surface, or not, for nearly 20 minutes. By the time they see the landing signal, they have already been waiting in silent uncertainty for a quarter of an hour or more. This is the moment, not the landing itself, but this moment in mission control during those silent minutes that captures something essential about the 38-minute problem. The people on the ground cannot help. They can only wait. They can only watch old data arriving in real time and know that the reality it describes is already past. They are, in a very precise sense, watching history. They cannot change it. They cannot intervene. They can only find out what happened. And when the landing signal arrives, when the data shows that the spacecraft touched down safely, that the crew is alive, that Mars has received its first human visitors, Mission Control erupts. Of course it does. But the crew landed 14 or 19 minutes ago. The crew has already run their initial post-landing checklists. The crew has already exchanged their first words on the Martian surface. The crew is already living on Mars, and the people on Earth are still reacting to the news of their arrival. The gap is already open. It opened the moment the spacecraft left Earth orbit. It has been growing ever since, and it will keep growing for months to come, because the landing is not the end of anything, it is the beginning. It is the moment when the crew transitions from transit mode, cramped, weightless, focused on the journey, to surface operations mode, where the full complexity of living and working on Mars unfolds. And it is the moment when the 38-minute window truly begins to define daily life. Because now the crew is not just travelling through the void. They are on the ground, in a habitat, running a mission that will last 18 months or more. The surface mission is where the 38 minutes stops being an abstract number and becomes a lived reality. It is where the crew learns, through direct experience, what it means to operate in a world where every communication with Earth is a message in a bottle, not a phone call. It is where the delay that seemed manageable in the transit phase, disorienting, yes, but manageable, begins to compound with all the other challenges of Martian surface operations. The Martian surface is not a benign environment. It is actively hostile to human survival in ways that are numerous and relentless. The atmospheric pressure, at roughly 600 to 800 pascals, is less than 1% of Earth's sea level pressure, instantly lethal to an unprotected human. The temperature swings from minus 80 degrees Celsius at night to perhaps positive 20 degrees Celsius on a warm afternoon near the equator, though the average is around minus 60. The thin atmosphere offers almost no protection from solar radiation or cosmic rays. The radiation environment on the Martian surface is roughly 40 times higher than on Earth's surface, accumulating biological damage that will eventually constrain the maximum mission duration. The soil contains perchlorates, toxic chemical compounds that are dangerous to human physiology if ingested, and that complicate any attempt at in situ food production. Dust storms can develop from localized events into global phenomena in a matter of weeks, reducing solar power availability to nearly zero and abrading every surface they contact. None of this is insurmountable. Every crewed Mars mission concept has addressed each of these challenges with specific engineering solutions: habitat pressure vessels, radiation shielding, nuclear or redundant solar power systems, dust filters and seal maintenance protocols. The solutions exist, but they require constant maintenance, constant monitoring, and constant, competent human attention on the surface, in real time, by the crew. And when something fails, when the dust filter clogs unexpectedly, when the habitat pressure drops, when a solar panel's support strut cracks under thermal stress, it is the crew who must diagnose it, the crew who must repair it, the crew who must decide whether to attempt the fix themselves or to abort an EVA or to trigger an emergency protocol. Mission Control can offer guidance, analysis, and support. But Mission Control's guidance will arrive 19 minutes after the crew's question, and the crew's acknowledgement of that guidance will take another 19 minutes to return. 38 minutes for a single exchange. In a habitat pressure emergency, 38 minutes is not a discussion, it is an aftermath. This is the world the first Mars crew will inhabit, not just physically, though the physical world is hostile enough, but informationally, epistemically. The crew will know things about their own situation that Earth does not yet know because the data takes 19 minutes to arrive. Earth will know things about the broader context, updated dust storm models, new geological data from orbital satellites, revised technical assessments from engineering teams that the crew does not yet know, because that information takes 19 minutes to arrive. Neither party has the complete picture. Both are working from slightly outdated information in slightly different directions across a gap that light itself takes 19 minutes to cross. This is the deepest nature of the 38-minute window. It is not just a communications delay, it is an information gap, a gap between what is happening and what is known, a gap that exists simultaneously in both directions, between the crew's knowledge of their own situation and Earth's knowledge of it, and between Earth's broader analytical capacity and the crew's ability to access it. The gap cannot be closed, but it can be managed. And the way it is managed, the procedures, the protocols, the crew dynamics, the psychological preparation, the trust between the surface team and the ground team will determine whether the first humans on Mars thrive or merely survive, or whether they come home at all. But here is something that the 38-minute problem forces us to confront, something that sits beneath the engineering and the psychology and the mission planning. The question of what we actually value when we send human beings to another planet. Because the communications delay is not incidental to the Mars mission, it is, in a strange way, definitional. Every other crewed space mission has been, at some level, an extension of Earth. The moon missions were extension cords, short, taut, never quite letting the astronauts fully leave. The ISS is an annex, remote but connected, a room in the house of Earth that happens to be orbiting above the atmosphere. But Mars is different in kind, not just in degree. Mars is a separation, and the 38-minute window is the physical measure of that separation, the amount of time it takes for the connection to Earth to traverse the gulf between the worlds. When we send people to Mars, we are, for the first time, sending people somewhere that Earth cannot reach them. not in any meaningful, real-time sense. We are sending people somewhere that their own judgment, their own courage, their own capacity to endure and adapt and solve and survive is all they have. That is a different kind of mission. It is, in some profound sense, the first mission that is truly about what human beings can do when they are entirely responsible for themselves. And the countdown to that moment, the slow growth of the delay from 5 minutes to 10 to 20 to 38, is not just an orbital mechanics timeline. It is a story about autonomy, about the moment when the tether breaks, not catastrophically, not all at once, but gradually, measurably, inevitably, and the people on the far end of it are left with nothing but each other and the red dust beneath their boots. In the next part, we are going to go inside that tether as it stretches. We are going to look at what the communications delay does to specific, concrete aspects of the surface mission, to medical care, to engineering decisions, to the psychological health of the crew. And we are going to trace the specific phases of the mission during which the delay crosses its critical thresholds. We are going to watch the gap open. There is a medical emergency that Mars mission planners think about more than almost any other. It is not the most dramatic emergency. It is not a fire or a hull breach or a catastrophic suit failure during an EVA. It is something quieter, more ambiguous, and in many ways more terrifying precisely because of its ambiguity. It is appendicitis. The human appendix is a small vestigial structure attached to the large intestine. In the vast majority of cases, it causes no problems whatsoever throughout a person's entire life. But in approximately 1 in every 1,000 people in any given year, the appendix becomes inflamed, a condition called appendicitis. And if it is not treated, the inflamed appendix can rupture, spilling bacteria into the abdominal cavity and causing a life-threatening infection called peritonitis. Without surgical intervention, a ruptured appendix is fatal in a significant percentage of cases. Even with modern antibiotics, the mortality rate from untreated peritonitis is substantial. On Earth, appendicitis is a routine surgical emergency. A patient presents with right lower quadrant abdominal pain, nausea, fever, and elevated white blood cell count. A diagnosis is made, usually within hours. An appendectomy is performed laparoscopically in most modern hospitals through 3 small incisions, and the patient is home within a day or two. The whole thing, from first symptoms to discharge, typically takes less than 48 hours. On Mars, appendicitis is a different kind of problem entirely. The crew carries surgical capability. Every serious Mars mission concept includes a medical module with the equipment necessary to perform basic surgical interventions, including an appendectomy. The crew includes at least 1 member with advanced medical training in most current mission concepts, a physician who has been trained specifically for austere environment surgery. The capability, in principle, exists, but capability is not the same as execution. Performing surgery in a pressurized habitat on Mars with a non-specialist crew assisting under conditions of stress and limited sterility is a fundamentally different undertaking than performing the same surgery in a hospital on Earth. And the 38-minute communications delay makes it different in a very specific way. Imagine the scenario. A crew member wakes on Mars Day 240 with abdominal pain. She rates it a 4 out of 10, uncomfortable, but not severe. She has had stomach problems before during the mission. The changes in diet, in gut microbiome, in physical activity patterns that come with living on Mars are well-documented sources of gastrointestinal discomfort. She notes it in her medical log. she takes the morning slowly. She attends her scheduled geological survey briefing. By midday, the pain has increased to a 7. She has a low-grade fever. She is nauseated. She tells the crew physician. The physician assesses her. He runs through the differential diagnosis, the list of possible conditions that could produce this symptom pattern. Appendicitis is on the list, so is ovarian cyst rupture, kidney stones, muscular strain, and a dozen other conditions. He wants guidance. He composes a detailed message to the flight surgeon on Earth describing the symptoms, the vital signs, the physical examination findings, his preliminary assessment, and his request for input on the differential diagnosis and recommended next steps. He sends it. 19 minutes pass. During those 19 minutes, the patient's pain increases to an 8. Her temperature rises. The physician begins preparing his diagnostic equipment, the portable ultrasound that will allow him to visualize the appendix if the image quality is sufficient, which on Mars, with a non-specialist operator, is not guaranteed. He is thinking through the decision tree. If it is appendicitis, does he operate now, before the appendix ruptures, or does he treat with antibiotics first and monitor? If he operates, who assists? How long will the procedure take? What are the anesthesia risks? The message from the flight surgeon arrives. It is excellent, detailed, specific, clear. It walks through the same differential diagnosis the physician has already been considering, confirms his clinical reasoning, suggests an ultrasound protocol, recommends specific blood tests that will help narrow the diagnosis. It advises against rushing to surgery before the diagnosis is confirmed. It is exactly the kind of guidance a physician in a remote location would want from a senior colleague. It describes the situation as it was 19 minutes ago. In those 19 minutes, the patient's condition has changed. The physician sends an update, new vitals, new symptom description, the results of his initial ultrasound attempt, which was inconclusive because the image quality was insufficient to clearly visualize the appendix through the bowel gas. He reports that the ultrasound was non-diagnostic. He asks whether he should attempt a CT scan. The Habitat carries a portable, low-resolution medical CT system, or whether he should proceed on clinical grounds. Another 19 minutes pass. Now 38 minutes have elapsed since the first message. The patient's pain is a 9. Her fever is higher. The physician is increasingly concerned that this is appendicitis, that it is progressing, and that the window for safe intervention before rupture may be measured in hours rather than days. He is making decisions. He is drawing up the anesthesia protocol. He is talking with the rest of the crew about who will assist in the operating space. The flight surgeon's response to his second message has not yet arrived. This scenario, and versions of it are run repeatedly in analog Mars mission simulations, captures something essential about the medical dimension of the 38-minute problem. It is not that mission control is unhelpful. The flight surgeon is highly competent, deeply engaged, doing everything right. The communication is not failing. The system is working exactly as designed. And yet the 38-minute gap means that the physician on Mars and the flight surgeon on Earth are, at every moment, working from different versions of the same patient. The physician is making decisions about a patient in real time. The flight surgeon is advising based on a patient who existed 19 minutes ago. By the time the flight surgeon's advice about the CT scan arrives, the physician has already done the CT scan. By the time the flight surgeon reviews the CT results and sends guidance on the surgical decision, the physician has already made the surgical decision. The flight surgeon is not driving the car. She's riding in the back seat, watching the road recede behind them, offering directions based on a map that is 19 minutes out of date. The physician on Mars knows this. He has always known this, in the abstract. But experiencing it, feeling the weight of a surgical decision with no real-time expert to confer with only his own training and the message in a bottle support from a brilliant colleague who exists, functionally, 19 minutes in the past, is different from knowing it. This is the medical reality of the 38-minute window, and medicine is only one domain in which it operates. Consider engineering. The habitat on Mars is, by design, an extraordinarily robust system. It has to be. Every component that could fail has redundant backups. Every backup has its own monitoring system. The engineering crew member, in mission planning documents sometimes called the systems engineer or the EVA specialist, is responsible for maintaining the physical infrastructure of the surface mission. And their job is essentially never done. There are always filters to check, seals to inspect, solar panel surfaces to clear of dust accumulation, power systems to balance, water recycling systems to monitor. But the habitat is also, by the nature of what it is, a system operating at the edge of its design envelope. It is exposed to a radiation environment that degrades materials faster than Earth testing always predicts. It is exposed to dust that infiltrates every seal and bearing and moving part with a thoroughness that ground testing never fully captures. It is subjected to thermal cycles, the daily swing from Martian night to Martian day, that stress every joint and connection in the structure. And it is operating with a maintenance team of, at most, 6 people, without any possibility of resupply or replacement parts for the duration of the surface mission. When something fails, and something always fails, in any complex engineering system operated over a long enough period, the crew must diagnose and repair it. And the 38-minute delay shapes every part of that process. The engineering team on Earth is vast. Mission control for a crewed Mars mission will have specialists in every subsystem of the habitat and the spacecraft. Power systems, thermal systems, life support, structural integrity, communications, propulsion. These specialists will be monitoring the telemetry data from Mars continuously, building models of system health, predicting failure modes, advising on maintenance schedules. They are an extraordinary resource, but they are a 19-minute-old resource. When the crew identifies a fault, when a sensor reading goes anomalous, when a system behaves unexpectedly, when a component makes a sound it has never made before, the standard procedure is to log the fault, run initial diagnostics, and transmit a report to Mission Control for analysis. Mission Control receives the report. Specialists review it. They run their own analyses, consult their engineering models, confer with the component manufacturers if necessary. They send back their assessment and recommendations. 38 minutes after the crew sent their report, Mission Control's initial guidance arrives. If the fault is progressing slowly, if it is a gradual degradation that will take days or weeks to become critical, this timeline is workable. The crew can afford to wait for analysis, to implement fixes carefully, to iterate on solutions with the ground team's input. But faults do not always progress slowly. Some faults are immediate. Some faults in a life support system are measured in minutes. Imagine a loss of pressure in the habitat airlock, not catastrophic, not explosive, but a slow leak that the sensors detect as a gradual decline in airlock pressure. The crew seals the inner airlock door immediately. Standard protocol, automatic response. The airlock is isolated. No one is in immediate danger, but the airlock is how the crew gets outside. It is how EVAs begin and end, and if the crew cannot identify and repair the leak, they are effectively confined to the habitat interior. The surface mission, the geological surveys, the sample collection, the equipment maintenance that requires external access stops. The crew sends a detailed fault report to Mission Control. They describe the pressure readings, the rate of decline before isolation, the location and configuration of the airlock seals. They run every diagnostic available to them from inside the habitat. They identify 2 or 3 possible failure modes and describe what they would need to do to verify and repair each one. Mission Control receives the report 19 minutes later. The engineering specialists go to work. They pull up the airlock design schematics, they model the pressure loss curve, they assess the most likely failure location, they prepare a detailed repair procedure. Their response arrives on Mars 38 minutes after the crew's report. In those 38 minutes, the crew has not been idle. They have been running their own analysis. They have been reviewing the airlock maintenance manuals of the same manuals that Mission Control is consulting, and they have almost certainly arrived at their own diagnosis and repair plan. They may have already begun the repair. The Mission Control response, when it arrives, may confirm what they are already doing, or it may suggest a different approach that they will need to evaluate against what they have already learned from their direct access to the system. This is not a failure of the support structure. It is the structure working as intended, with the delay built in. But it means that the crew is, at every moment, effectively operating one step ahead of Mission Control's knowledge of their situation. They are the ground truth. Mission Control is the model. And the model is always 19 minutes behind the truth. Over months of surface operations, this dynamic accumulates into something that mission psychologists call autonomy drift. The crew gradually becomes more self-reliant, not because Mission Control is inadequate, but because the delay makes it structurally necessary. The crew begins to solve problems before Mission Control has finished analyzing them. They develop their own expertise in the specific quirks of their particular habitat and equipment, an expertise that is grounded in direct physical experience and that cannot be replicated by any model or manual on Earth. They build their own institutional knowledge of Mars, and as autonomy drift accumulates, the psychological relationship between the crew and Mission Control slowly transforms. In the early weeks of the surface mission, when the delay is still relatively short and Mission Control's guidance still arrives quickly enough to be immediately actionable, the crew defers frequently and instinctively. They send reports and wait for responses. They check in before making non-trivial decisions. The operational culture they have brought with them from Earth, the ISS, derived culture in which the ground team is a constant and authoritative presence, still shapes their behavior. But as the delay grows, as the months pass and the orbital geometry shifts, the crew begins to change. The change is not dramatic. It does not manifest as rebellion or resentment. It manifests as quiet competence. The crew stops waiting. They report to Mission Control comprehensively and consistently, but they report what they have done rather than asking what to do. Their messages shift in tone from inquiries to briefings. They are not seeking permission. They are informing a record. Mission Control, watching this transformation in the content and tone of the crew's communications, experiences its own version of the transition. The specialists, who have spent months deeply engaged in the analysis and guidance of every aspect of the mission, gradually find that their expertise is being consulted less urgently and more reflectively. They are no longer the first call in a crisis. They are a second opinion, delivered late, A confirmation sought after the decision has already been made. Their role evolves from operational controllers to strategic advisors, valued, respected, consulted deeply on complex, long-horizon questions, but no longer the real-time voice in the crew's ear. This transition is necessary, it is healthy, but it is also, for the people on the ground who have dedicated years of their lives to this mission and who feel genuine, profound responsibility for the safety of the people they sent to Mars. It is hard. The loss of real-time operational authority is experienced by some mission controllers as something close to grief. And then there is the personal dimension. Because the 38-minute delay does not only affect the operational communications between the crew and mission control, it affects every communication between the crew and Earth, including the personal ones. The people on a Mars mission are not just operational units, they are human beings with families, with relationships, with emotional lives that do not pause for the duration of the mission. They have parents who are aging and may not be in good health. They have partners who are raising children alone or navigating their own careers and emotional needs, or simply enduring the particular loneliness of being left behind by someone who went to another planet. They have friendships and communities and all the texture of a human life that continues on Earth while they are gone. And they communicate with that life across a 38-minute delay. Personal communications on a crewed Mars mission will be among the most psychologically significant aspects of the entire mission experience, and they are among the least studied. The operational psychology of the mission, how the crew makes decisions, how they manage conflict, how they maintain group cohesion, has been analyzed extensively in analog studies and simulation programs. But the personal communications dimension is harder to study because it is harder to simulate. You cannot really replicate in a one-year analog study in Antarctica or in the NASA Mars habitat on Hawaii the experience of sending a video message to your 10-year-old child and receiving their response 38 minutes later. A child who has grown and changed and had experiences you were not present for, who is recording their message in a house that you have not stood in for 18 months. What we know from existing research on long-duration isolation, from Antarctic expeditions, from submarine deployments, from ISS missions, is that personal communications are enormously important to crew psychological health, and that the quality of those communications matters more than the quantity. A brief, genuine, emotionally present message from a loved one is more sustaining than hours of perfunctory check-ins. And the delay, even a delay much shorter than 38 minutes, changes the texture of communication in ways that matter. On a Mars mission, the 38-minute delay means that personal communications take the form of asynchronous video messages. You record a message, you send it. 38 minutes later, it arrives. The person on the other end watches it, records their response, and sends it. 38 minutes after that, you receive it. A single exchange takes 76 minutes minimum. A back-and-forth conversation of 4 or 5 exchanges, the kind of conversation in which you might share something meaningful, hear a response, respond to that response, and arrive at some emotional resolution, takes 4 to 6 hours of wall clock time. Many crew members in long-duration mission simulations report that this rhythm eventually changes the nature of what they say. They learn to front-load more into each message, to ask the questions they want answered, to share the things they want to share, to anticipate the responses they are likely to get and pre-address them, because each message is expensive in terms of turnaround time. They become, in their personal communications, more deliberate and less spontaneous, more composed and less reactive, more like letter writers and less like conversationalists. Some crew members find this surprisingly rich. The enforced deliberateness of the medium they report makes them more thoughtful about what they say and how they say it. They pay more attention to each message they receive because each message costs time and intention and something like courage to produce. They feel, paradoxically, more deeply connected to the people they are communicating with than they do during the real-time, low-stakes, easily forgotten phone calls of daily life on Earth. Others find it devastating. The delay, for these crew members, is not a different mode of connection, but an amplification of disconnection. Every 38-minute gap feels like a wall. Every message sent into the void and not yet returned feels like a question hanging in the air. The cumulative weight of all the moments they have missed, all the ordinary days at home that have happened while they were on Mars, all the conversations that took place without them, all the small events that make up a life and that they will only ever hear about second-hand, settles onto them with a heaviness that the operational busyness of the mission can sometimes mask but never fully lift. This is the human face of the 38-minute window, not the engineering problem, not the operational challenge, the face of a person on Mars who just sent a birthday message to their daughter and is waiting, in the silence of a Martian night, for a response that is 38 minutes away. And while they wait, Mars is doing what Mars does. The temperature is dropping, the dust is settling. The moons, Phobos and Deimos, small and irregular and strangely close, are crossing the sky in their rapid orbits, Phobos rising in the west and setting in the east, because it orbits Mars faster than Mars rotates. The horizon is sharp and close because the planet is smaller than Earth and the curvature is perceptible in a way that is slightly disorienting to anyone who has grown up on Earth's gentler arc. The stars, through the thin Martian atmosphere, are brilliant, more brilliant than they appear from Earth's surface, though the atmosphere still produces a faint scattering that dims the very faintest ones. The crew member waiting for their daughter's birthday response sits at the communications terminal and looks at the timestamp on their sent message. They calculate when the response should arrive if she sent it immediately after watching. They add the margin for the fact that she's probably in school and will not see the message until evening. They look at the Martian sky and do the math in their head. Tomorrow morning. At the earliest, tomorrow morning. On Earth, this would be the most ordinary kind of waiting. The waiting that everyone does every day in the gaps between messages and calls and moments of contact. The waiting that is simply the texture of love at a distance. On Mars, it is something more. It is a measurement, a physical measurement in minutes of how far they are from everything they have ever known. 38 minutes at its worst, closer to 8 or 10 in this particular week of the mission, but growing. Always growing as the orbits turn and the distance widens and the universe measures in the language of light travel time, exactly how alone a human being can be. This is the window, seen from inside. And there is a moment coming, a specific, calculable moment in the mission timeline when the window closes further still. When the delay crosses a threshold that is not just operationally significant, but symbolically profound. When the gap between Earth's knowledge of the crew's situation and the crew's lived reality grows wide enough that mission control begins, quietly and with great sorrow, to revise its own understanding of its role. The moment when the ground team sends a message and knows with full certainty that whatever they have said is already history by the time it arrives, that the crew has already moved on, that Earth is not guiding the mission anymore. Earth is witnessing it. That moment is coming, and understanding it requires looking at the specific architecture of the mission timeline, at the phases and thresholds and turning points that mark the slow transformation of a supported mission into something genuinely unprecedented. In the next part, we are going to walk through those phases in detail. We are going to trace the delay curve from the surface mission's early days through the critical mid-mission period when the operational culture shifts, and into the darkest stretch of any crewed Mars mission, the solar conjunction blackout, when the delay does not merely reach 38 minutes but disappears altogether, when there is no signal, no confirmation, no voice from home, only Mars. There is a chart that every Mars mission planner knows by heart. It is not a complex chart. It has a single horizontal axis, time measured in days from the start of the surface mission, and a single vertical axis, one-way communications delay, measured in minutes. The line it traces is not straight. It curves. It rises and falls with the orbital mechanics of the two planets climbing through the early months of the surface mission, peaking somewhere around the middle of the stay, then beginning, slowly, unevenly, to descend as the planets begin their long approach to the next opposition. But the descent is deceptive, because before the line falls, it does something else, something that no chart can fully prepare you for. It disappears. For a period of approximately 2 weeks, somewhere near the middle of a typical 18-month Mars surface mission, the line simply vanishes. The communications delay does not reach some maximum and hold there. It reaches a maximum, and then it becomes infinite. The signal does not slow down, it stops. Not because of equipment failure, not because of any human error or systems fault, because the sun gets in the way. This is solar conjunction, and it is the moment that every Mars mission, every robotic mission certainly, and every crewed mission that will ever follow must pass through. But before we reach the blackout, we need to walk the curve, because the blackout does not arrive without warning. It is preceded by weeks and months of preparation, of escalating operational changes, of psychological adjustment. The 2 weeks of total silence are the culmination of a process that begins on the first day of the surface mission and builds day by day through a series of thresholds that each carry their own weight. Day 1. On the Martian surface. The delay, depending on the mission's launch window, is somewhere between 8 and 14 minutes each way. This is the number the crew has been briefed on, trained for, psychologically prepared to accept. And in the early days of surface operations, it is manageable in a way that feels almost reassuring. A confirmation that the preparation was adequate, that the reality is not worse than the simulation. Mission control is deeply engaged. The first days on the Martian surface are among the most data-rich of the entire mission, with the crew running systems checks, conducting initial habitat surveys, performing their first EVA assessments, and generating a continuous stream of operational reports. The ground team is absorbing all of it, analyzing, responding. The delay means that responses arrive 10 to 30 minutes after the questions. But the questions are not usually urgent. They are the questions of a crew that is carefully and methodically establishing its operational baseline, not a crew in crisis. The first weeks feel like an extended version of the transit phase. The crew is busy, focused, buoyed by the extraordinary fact of their presence on Mars. The psychological literature on analog missions consistently reports a honeymoon period in the early stages of surface operations, during which the novelty and the sense of achievement temporarily suppresses the isolation effects that will emerge later. The crew is on Mars. They are doing what they came to do. The 38-minute problem exists in the background of their awareness, acknowledged but not yet felt in its full weight. By day 30, the delay has grown. Depending on the specific orbital geometry, it may now be 15 to 18 minutes each way. The round trip is 30 to 36 minutes. Mission control is still deeply engaged, but the operational rhythm has shifted. Responses arrive less frequently in the middle of an evolving situation and more often as considered assessments of situations that the crew has already handled. The crew has begun to develop its own on-site expertise. The habitat has been fully commissioned. The initial survey data has been collected and transmitted. The mission has moved from establishment phase into operational phase, and the day-to-day rhythm of surface work has settled into something that feels, in its structure, if not its location, like the deep routines of any long-duration field expedition. Day 60. The delay is now approaching 20 minutes each way, and something subtle but measurable has changed in the communications logs. When researchers analyze the message traffic of long-duration missions, both real ones, like ISS expeditions, and simulated ones, like the Mars 500 isolation study or the HIC's analog missions in Hawaii, they look for specific linguistic markers that indicate the crew's psychological relationship to the ground team. Certain patterns of language correlate with healthy crew-ground dynamics, collaborative framing, explicit acknowledgement of ground input, questions that seek genuine consultation rather than post hoc validation. Other patterns correlate with deteriorating dynamics, reduced message frequency, increasingly brief operational reports, a shift from collaborative to declarative language, and one of the subtler markers, a change in the use of future tense versus past tense when describing decisions. A crew that says, "We are planning to attempt the seal repair tomorrow, pending your input," is still operating in a collaborative mode. A crew that says, "We repaired the seal yesterday, results were satisfactory," has moved into a reporting mode. The difference is not about competence or insubordination. It is about the delay. When the delay makes it functionally impossible to receive input before a decision must be made, the crew stops asking for input before making decisions. The language adjusts to reflect the reality. By day 60, in most mission simulations, the communications logs show this shift beginning. It is gradual. It is not uniform across all message types. The crew continues to consult mission control on strategic and medical questions, where the longer planning horizon makes the delay less prohibitive. But on operational and engineering decisions, the declarative mode is increasingly dominant. Mission control notices. The mission controllers who have been monitoring this mission for years, who have followed the crew through training, through transit, through the first weeks on the surface, see the shift in the logs and feel its meaning. They do not flag it as a problem, because it is not a problem. It is an adaptation. But they feel it as a change in the nature of their relationship with the crew. The daily briefings that Mission Control sends to Mars, detailed, carefully prepared, full of analysis and recommendation, are still being received and read. But they are increasingly informing the crew's thinking rather than directing the crew's actions. Earth is becoming a resource rather than a command authority. And the people on Earth are learning to inhabit that new role, with all the difficulty that entails. Day 90. 3 months into the surface mission, the delay is now 22 to 24 minutes each way, and the mission enters what planners call the mid-mission transition. the period during which several important operational changes are formally implemented. The first change is the revision of the Decision Authority Matrix. Every Mars mission will have a formal document that specifies which decisions require ground approval, which require crew commander authority only, and which can be made by any crew member acting within their domain of expertise. In the early mission phase, when the delay is short, the list of decisions requiring ground approval is relatively long. As the delay grows, that list formally contracts. At the mid-mission transition, the document is updated. The threshold for decisions that require ground consultation is raised. More decisions are delegated to the crew commander. More decisions within specific domains, medical, engineering, scientific, are delegated to the relevant specialist. This is not a crisis response, it is a planned transition anticipated from the beginning of mission planning, executed at the point where the delay makes the prior authority matrix operationally untenable. But it is still a transition that carries psychological weight for everyone involved. The mission director on Earth signs a document that formally acknowledges that the crew commander on Mars now has authority over decisions that, 3 months ago, required ground approval. The mission director understands why this is necessary. They have understood it for years, but signing the document is different from understanding the necessity of signing it. The second change at the mid-mission transition is the restructuring of the daily communication schedule. In the early mission phase, mission control and the crew exchange multiple updates per day: morning briefing, afternoon status report, evening summary. As the delay grows, this schedule becomes less and less like a dialogue and more like a parallel monologue, with mission control sending comprehensive daily packages to Mars and the crew sending comprehensive daily packages to Earth, each unaware of what the other has sent until the respective packages arrive. At the mid-mission transition, the communication schedule is formally revised to match this reality. The multiple daily exchanges are consolidated into one comprehensive daily package in each direction. Mission Control prepares a single detailed document each day: engineering analysis, medical updates, scientific data interpretation, psychological support resources, personal messages from families, and transmits it to Mars. The crew prepares a single detailed daily report: operational summary, system status, scientific findings, medical logs, personal messages home, and transmits it to Earth. The communication is rich, it is thoughtful, it is, in many ways, more substantive than the fragmented real-time exchanges of the early mission phase, but it is undeniably slower, and slower in the rhythm of human emotional life is felt as more distant. The crew is getting one package from Earth per day, one collection of voices and faces and words from home, arriving in a single daily transmission like a newspaper delivered to a remote research station. Informative, valued, deeply appreciated, and completely unlike the continuous ambient presence of home that human beings are accustomed to in the connected world of the 21st century. Day 120. 4 months into the surface mission, the delay is approaching 26 minutes each way. The round trip is now over 50 minutes, which means that even a simple question and answer exchange, even a single operational query with a single response, takes nearly an hour to complete. Any situation that develops faster than an hour is handled entirely by the crew before mission control has an opportunity to weigh in. And it is around this point in the mission that the crew begins to experience something that the psychological literature calls the overview effect in reverse. The overview effect, The cognitive and emotional shift reported by most astronauts who have seen Earth from space is a sense of the planet's wholeness, its fragility, its unity. Astronauts looking down at Earth from orbit frequently report feeling a profound connection to the planet and to humanity as a whole, a dissolution of the artificial boundaries between nations and peoples, a sense of belonging to something vast and precious. The reverse overview effect, experienced on Mars, is more complicated. It is not the overview effect's opposite, a cold detachment from Earth, an indifference to the home planet. It is subtler than that. It is a gradual recalibration of the crew's sense of where they belong. Earth, seen from Mars, is a point of light, a blue-white dot, visible to the naked eye on a clear, Martian night, prominent enough to cast a faint shadow if you hold up your hand under its light, but still a dot, a thing in the sky, not a home you can reach, not a place you can return to in any near-term sense, a destination that is months away in the best-case scenario, and that, for much of the surface mission, is getting farther rather than closer. The crew does not stop loving Earth. They do not stop missing it. But their relationship to it changes. It becomes, for some crew members, more abstract. The planet that was the only world they had ever known, the planet of their childhoods and their families and their entire prior existence, is now, from where they stand, a star. And the delay that separates them from it is not just a technical fact, but a felt reality, a thing that lives in the body as a kind of chronic, mild grief. Psychologists studying Mars analog crews report that the fourth and fifth months of a surface mission, the months corresponding to this period in the delay curve, are among the most psychologically difficult. The honeymoon is definitively over. The operational routines are established, and with establishment comes a certain flatness, a loss of the novelty that sustained early mission morale. The end of the mission is still many months away, too far to provide the forward momentum that the final months will eventually generate. The crew is in the middle, in the longest and most featureless stretch of the mission timeline, and the communications delay is now long enough to be a daily psychological presence rather than a background inconvenience. This is when interpersonal friction peaks, when the small irritations of shared confined living that were tolerable in the early mission become larger, when the crew member who chews loudly or who leaves equipment in the wrong place or who takes slightly too long in the hygiene module becomes, irrationally but powerfully, a source of disproportionate frustration. When the crew commander, who has been managing everyone else's morale, quietly begins to struggle with their own. Mission controllers monitoring crew communications for psychological health markers are watching carefully during this period. The flight psychologist is in close contact with the crew, sending regular structured check-ins and receiving detailed responses. Personal communications from families are curated and timed with particular attention to their psychological impact. Important family news is not simply transmitted at the moment it occurs, but is considered in context of the crew member's current psychological state before it is sent. This curation itself is a product of the 38-minute delay. On the ISS, where communications are essentially real-time, the psychological support infrastructure operates reactively, monitoring crew well-being in real time and responding to emerging issues as they develop. On Mars, with a 26-minute one-way delay, reactive support is structurally limited. By the time Mission Control identifies a psychological concern from the crew's communications and formulates a support response, the crew member in question has already been living with whatever triggered the concern for at least 26 minutes, and the support response will take another 26 minutes to arrive. 52 minutes minimum for a single support exchange, during which the crew member is managing alone. This means that Mars mission psychological support must be largely proactive and anticipatory rather than reactive. The flight psychologist does not wait for problems to emerge. She runs regular structured assessments, psychological equivalent of the engineering diagnostics that monitor habitat systems, and looks for early indicators of emerging difficulty. She develops detailed individual psychological profiles of each crew member and maintains them throughout the mission, updating predictions and intervention plans as the mission evolves. She prepares and pre-positions psychological support resources, recorded messages from family members, structured exercises, cognitive behavioral tools that can be deployed at specific points in the mission timeline when the research suggests they will be most needed. It is, in a strange way, a form of psychological time travel. The flight psychologist on Earth is doing her most important work before the problems she is addressing have fully developed, because by the time they fully develop, the delay will mean that her responses are always arriving late. Day 160. The surface mission is approaching its midpoint, and the delay curve is climbing towards something that has been visible on the chart since the mission began. Somewhere around day 180 to 200. Depending on the specific orbital geometry of this particular mission, the line will reach its conjunction period maximum, and then it will do what the mission planners have always known it would do. It will disappear. The approach to solar conjunction is not sudden. It is gradual, and it is announced by a specific technical phenomenon called solar corona noise, the increase in signal degradation caused by the solar plasma that begins affecting communications weeks before the actual conjunction. As Mars approaches its position behind the Sun, the radio signals passing between Earth and Mars must travel through an increasing volume of coronal plasma, which scatters and absorbs radio waves in ways that reduce signal quality, increase data error rates, and eventually, as the angular separation between Mars and the Sun drops below about 2 degrees, render communications impossible. The crew knows conjunction is coming. They have known since before they left Earth. The mission timeline has always included the conjunction blackout as a planned operational event. In the months before conjunction, Mission Control and the crew have been collaboratively preparing for it, with a thoroughness that is itself a kind of communication, a long, detailed conversation about everything that might happen during the blackout and everything the crew should do if it does. This preparation takes the form of what mission planners call the Conjunction Playbook, a comprehensive set of pre-approved protocols, decision guides, and contingency plans, covering every credible emergency that might occur during the 2-week blackout. Medical emergencies, engineering failures, EVA accidents, interpersonal crises. The Conjunction Playbook is not a simple manual. It is an attempt to anticipate the future, to think through in advance every decision that might need to be made during the blackout, so that when the crew faces those decisions in real time, they are not making them from scratch. They are implementing a plan that they helped create, that Mission Control helped create, that represents the combined knowledge and judgment of the entire mission support team, distilled into a form that can function without any real-time input from Earth. The Conjunction Playbook is, in a deep sense, the physical embodiment of the trust between the crew and the ground team. It is Mission Control's answer to the question that the 38-minute delay poses with increasing urgency throughout the surface mission. What do you do when we can't help you? We will have already helped you, the playbook says. We helped you before we lost contact. We put everything we know into this document and we trust you to use it. The week before conjunction, Mission Control transmits what the crew calls the final package, a massive data transfer containing updated versions of every technical manual, every medical protocol, every scientific database, every piece of information that the crew might conceivably need during the blackout. It contains personal messages from families, longer and more emotionally complete than the daily packages, because these messages must sustain the crew through 2 weeks of silence. The communications team on Earth works extended shifts, maximizing the information transfer, while the window is still partially open. And then, on a specific day that was calculated years before the mission launched, a day whose date is known with precision because orbital mechanics is not ambiguous, the signal drops below the minimum usable threshold. Mission Control sends a final message. The crew receives it or most of it. They send a final response. Mission Control receives it or most of it. And then there is silence. Not metaphorical silence, not the stretched, delayed silence of a 38-minute gap. Actual silence. The communications terminal on Mars receives no signal from Earth. The Deep Space Network antennas on Earth receive no signal from Mars. The two planets, separated by 400 million kilometers with the Sun between them, are completely and totally out of contact with each other. For the crew on Mars, the silence arrives at a specific moment, a moment they have anticipated for months, a moment they have been prepared for to the extent that preparation is possible. And it is still, by every account, from analog mission simulations and from the accounts of remote expedition teams who have experienced planned communication blackouts, one of the most psychologically significant moments of the entire mission. It is not the silence of a broken connection. It is the silence of a completed one. For the duration of the conjunction, there is no connection to complete or break. Earth does not exist in any communicative sense from the crew's perspective. They are sending no messages. They are receiving no messages. The terminal is dark. The Deep Space Network is silent. The blue-white dot in the Martian sky is on the other side of the Sun. What is it like in that silence? The analog studies give us some texture. In the Mars 500 study, a 520-day isolation experiment conducted in Moscow between 2010 and 2011, the crew was subjected to simulated communication delays and simulated blackout periods. What researchers found during the blackout simulations was counterintuitive to many of the psychologists involved. The crews did not, in most cases, experience the blackout as a period of heightened anxiety. They experienced it as a period of strange, uncomfortable, but ultimately clarifying solitude. The removal of Earth's presence, even the delayed, asynchronous presence of the communication packages, produced in many crew members a kind of psychological settling. The white noise of home fell silent. What remained was the mission, the habitat, the crew, and Mars. Some crew members reported that the blackout was when they felt most genuinely present on Mars. Not because they enjoyed the isolation, and they did not on the whole, but because the isolation was total enough that there was nothing to do with it but inhabit it. There was no point in composing messages that could not be sent. There was no waiting for packages that could not arrive. There was only the work, and the people, and the planet outside the habitat windows. Others experienced the blackout differently. For crew members with significant personal concerns on Earth, a parent in poor health, a relationship under strain, a child going through a difficult period, the 2 weeks of complete silence were experienced as an extended suspension of the worst kind. Not knowing, being unable to know, sending nothing and receiving nothing, while life on Earth continued at its normal pace, with all its normal contingencies utterly beyond reach or knowledge. For these crew members, the blackout was a confrontation with the most fundamental aspect of the 38-minute problem, an aspect that the delay itself only partially reveals, but that the blackout makes nakedly clear. On Mars, you cannot be there when it matters. Not for emergencies on Earth, not for the moments that define a life and a relationship. Not for the last days of a parent's illness, or the first days of a child's new school year, or the slow deterioration of a partnership that needed presence and attention and could not survive on video messages alone. You are on Mars. You are 38 light minutes away at best, and currently 400 million kilometers behind the Sun, and there is nothing you can do about any of it. This is the existential weight of the conjunction blackout. It is not just an operational challenge, it is a confrontation with the price of being the kind of person who goes to Mars. And that price is real. It is paid by the crew members themselves who chose this and who will live with the weight of what they missed. It is paid by the families who were left behind, who supported the mission and who also bore its costs in ways that the mission timeline charts do not capture. It is paid by the relationships that did not survive, by the moments that were not shared, by the presence that could not be given across 400 million kilometers and a solar corona, and the inflexible physics of the speed of light. But it is also, and this is what makes it bearable, or at least what the people who go to Mars will need to believe makes it bearable, paid in service of something. Something that is worth the price. Something that changes what it means to be human, that expands what we are capable of, that opens a door that has never been opened before in the 4-billion-year history of life on this planet. Whether that price is justified is a question that each person who considers going to Mars will have to answer for themselves, and it is a question that will not be answered in the abstract. It will be answered in the specifics, in the particular texture of a particular person's life, in the particular relationship between what they are leaving and what they are going toward. But the conjunction ends. That is the thing that sustains the crew through the 2 weeks of silence. The silence is not permanent. The blackout has a duration. It was calculated in advance. It is already over, in a sense, because the date on which it ends was known before the mission launched. The crew counts down the days of the blackout with a focus and a dedication that is, in its own way, a form of the countdown that defines this entire mission. And then, on the day broken by a carrier wave. What comes through in those first fragmented packets before the signal quality improves enough for complete messages? Before the full conjunction recovery package arrives, before the voices of family members and flight surgeons and mission controllers emerge from the noise, is something very small, a timestamp, a frequency, a handshake protocol that says, in the language of radio engineering, "We are here." And on Mars, the crew hears it, not metaphorically. They hear the carrier wave, they hear the noise and the error bursts and the fragmented data headers. And they understand what it means. Earth is here. The window is open again. And now, in the final part of this story, we must reckon with what happens after, with what the crew brings back from conjunction, from the silence, from the 2 weeks of being genuinely alone on another planet, with what it means to re-enter contact with Earth after the deepest isolation any human being has ever experienced, and with the question that this entire journey, from launch to transit to landing to conjunction to the long post-conjunction stretch of the mission, has been building toward. What does it do to a person to have stood in that silence? What do they bring back? And what does it mean for the future, for the next crew and the one after that, and all the crews that will follow, each of them counting down to their own 38-minute window, their own conjunction, their own confrontation with the furthest edge of human solitude? There is a concept in psychology called post-traumatic growth. It is distinct from resilience, which is the capacity to absorb difficulty and return to a prior state of functioning. Post-traumatic growth is something more specific and more surprising. It is the phenomenon by which certain individuals, after passing through experiences of profound difficulty or loss, emerge not merely restored, but genuinely transformed. Not the same person, repaired. A different person expanded. Someone for whom the experience, however painful, has produced a change in perspective, in values, in the understanding of what matters, that would not have been possible without the ordeal itself. Post-traumatic growth has been documented in survivors of illness, in combat veterans, in people who have lost loved ones, in anyone who has been brought to the edge of what they can endure and found at that edge something unexpected. Not peace necessarily, not resolution, but a kind of clarity that ordinary life rarely provides. A clarity about what is real, what is fragile, what is worth protecting, and what was never as important as it seemed. The crews who return from Mars will carry something like this. Not all of them in the same way, not all of them without cost. The experience of 18 months on the Martian surface, of the growing isolation, the shifting communications delay, the mid-mission psychological trough, the conjunction blackout, the long post-conjunction stretch toward the return launch window, is not uniformly transformative in a positive direction. Some crew members will return with wounds that take years to understand and address. Some relationships will have been permanently changed by the absence, the silence, the 18 months of 38-minute gaps. Some things that were left on Earth will not be there in the same form when the crew returns. But the people who went to Mars will be different from the people who left. And the difference will be shaped more than almost anything else by the experience of the communications delay, by the specific, daily, lived reality of being separated from Earth, not just by distance, but by time. This is what we need to understand about the post-conjunction phase of the mission, because it is during the weeks and months after the blackout ends that the full meaning of the experience crystallizes, not during the blackout itself, which is too immediate and too absorbing for much reflection, but in the aftermath, when the signal is restored and the crew re-enters contact with Earth and discovers gradually and with some surprise that the contact feels different than it did before. The signal comes back. The communications terminal comes alive. The conjunction recovery package arrives. 2 weeks of accumulated daily packages from mission control, 2 weeks of personal messages from families, 2 weeks of Earth's news and data and voices, all arriving in one enormous, compressed transmission that takes hours to fully download and process. The crew goes through it carefully, each member taking their personal messages privately, reading and watching in the particular silence of someone who has been waiting a long time for something they needed. What they find in those messages is that Earth continued. Of course it continued. They knew it would continue, but knowing it and experiencing it are different things. And the conjunction recovery package makes it viscerally, specifically real. 14 days of life on Earth compressed into a data package on a Mars terminal, 14 days of their children's lives, their parents' health, their partners' experiences, their friends' ordinary days. 14 days during which, from Earth's perspective, the crew on Mars was simply gone, unreachable, beyond contact, existing only as an anxiety and a hope in the minds of the people who loved them. And now, they are back. Not physically. They are still on Mars, still many months from the return launch window, but communicatively. The 38-minute delay has resumed. The signal is real. Mission control is on the line. But here is what the post-conjunction period reveals, and what makes it one of the most psychologically interesting phases of any Mars mission. Re-entry into contact with Earth after 2 weeks of total silence is not simply a return to the pre-conjunction normal. It is an encounter with a changed relationship. The crew has changed. They have been through something. The specific something of 2 weeks of complete communicative isolation on another planet that no one on Earth has experienced, that no training fully simulated, that no amount of preparation entirely anticipated. They have operated entirely on their own authority for 14 days. They have made every decision, handled every situation, resolved every interpersonal tension, managed every operational challenge without any input from Earth. They have discovered in the most concrete way possible that they can. And this discovery changes the nature of the contact when it resumes. Mission controllers who have studied Mars mission simulations and analog programs describe a consistent pattern in the post-conjunction communications. The messages from the crew are different, not dramatically, not in a way that sounds alarm bells or indicates a problem. Different in texture. The crew is warmer towards the ground team. The relief and gratitude of restored contact is genuine and palpable. But they are also, in some subtle but measurable way, more settled in their own authority. The deference that characterized some of the early mission communications is less present. The crew is not dismissive of mission control's input. They are genuinely glad to have it, but they are engaging with it from a position of established competence rather than from a position of trained dependence. They have learned something about themselves during conjunction that has permanently updated their self-understanding. They know what they can do. They know what their crewmates can do. They know that the protocols and the training and the preparation that went into this mission are adequate. Not because mission control told them they were adequate, but because they tested those protocols and that training and that preparation against 14 days of reality without a safety net. And the protocols held. This is the post-conjunction crew, and this is the crew that must now navigate the final stretch of the surface mission. The post-conjunction phase of a Mars surface mission is, in most mission timelines, roughly 6 to 8 months long, the period between the end of the communications blackout and the launch window for the return journey to Earth. It is the longest continuous operational stretch of the mission because the pre-conjunction phase is divided into establishment early operations and the conjunction approach, each with its own distinct character. The post-conjunction phase is longer and more uniform, and it arrives when the crew is at its most experienced and most autonomous. The communications delay in the post-conjunction phase is initially still quite long, 20 to 25 minutes each way in the weeks immediately after conjunction end, but it is now declining rather than growing. Day by day, as the orbital geometry shifts and Earth begins its gradual approach toward the next opposition, the delay curve that spent months climbing begins, slowly and unevenly, to descend. The crew watches the delay shrink. the way a traveller watches the city lights brighten on the horizon during the last miles of a long journey home. But it shrinks slowly, and the crew has work to do. The post-conjunction phase is, scientifically, the richest part of the surface mission. The crew has spent the entire mission building toward this point, establishing their operational baseline, calibrating their equipment, developing their geological and atmospheric knowledge of the landing site. They are now at their most capable, their most efficient, their most deeply integrated into the specifics of their particular corner of Mars. The scientific return in the post-conjunction phase typically exceeds the combined scientific return of all prior phases, because capability compounds. A crew that has been on Mars for 10 months knows things about Mars, specifically, locally, practically, that no one on Earth knows, and that no orbital data or robotic precursor mission could have revealed. They know which rock formations are unstable underfoot and which are solid. They know which wind directions precede dust events at their specific location. They know the thermal quirks of their habitat, which walls run cold at night, which systems need an extra few minutes to stabilize after a temperature swing, which airlock seal requires a slightly unorthodox technique to achieve a reliable pressure check. They know each other, not in the way that 2 years of training produces familiarity, but in the way that 18 months of shared extremity produces something closer to the kind of deep, functional knowledge that combat units and polar expeditions develop, where each person understands not just the other's capabilities, but their patterns, their warnings, their breaking points, and their recovery rhythms. This crew is not the crew that launched from Earth. They have been shaped by Mars, by the delay, by the isolation, by the conjunction, by everything that happened in the 38-minute window and in the silence that the window eventually gave way to. And now, in the post-conjunction phase, they are beginning to look toward home. Not with impatience, not with the restless urgency of people desperate to leave. They are too deep in the mission for that, too committed to the work, too embedded in the operational rhythm of the surface, but with a growing awareness of the return that is coming. With the beginning of the psychological process of reorientation that the mission psychologists call re-entry preparation. Re-entry preparation for a Mars mission is different from re-entry preparation for an ISS expedition. ISS crew members returning from 6-month missions face genuine challenges: physical reconditioning after months of microgravity, psychological adjustment to the noise and stimulation of Earth after the quiet routine of the station, the re-navigation of personal relationships that have been maintained at a distance for 6 months. These are real challenges, and they are taken seriously. But the Mars crew is coming back from something categorically different. They are coming back from the longest, most isolated, most communications delayed crewed mission in the history of human spaceflight. They are coming back from a world where every interaction with Earth was mediated by a 38-minute gap. They are coming back from conjunction. They are coming back as people who spent 18 months operating with a level of autonomy and self-sufficiency that no human beings have ever been required to sustain. And they are coming back to a world where everything is immediate. This is the challenge that mission psychologists call re-entry shock, and it is one of the most underappreciated aspects of the entire Mars mission psychology. The crew has adapted to the 38-minute delay. They have internalized it, built their operational rhythms around it, restructured their communications patterns to accommodate it. They have learned to wait, to compose, to send a message and then turn back to the work and not expect an answer for 38 minutes, to make decisions without confirmation, to exist in a state of comfortable, functional autonomy from Earth. And then they return to Earth, where the latency is zero, where the phone rings and someone is there, where mission control can see what you are doing in real time and respond in real time, where your family is in the same room or at most a few seconds away, and there is no delay, no gap, no light travel time between you. For some returning Mars crew members, this immediacy is overwhelming. The constant availability of connection, the fact that everyone and everything is always reachable, always present, always demanding a response, is experienced not as welcome relief, but as a kind of cognitive and emotional flooding. They have spent 18 months in a world where every communication required intention and effort and patience. They return to a world where communication is frictionless and constant and impossible to escape. The adaptation runs both ways. The delay was hard to adapt to, but it was also, once adapted to, in some ways a cleaner way of living. More deliberate, more considered, less reactive, and returning from it requires its own adjustment, a decompression from the particular quality of Martian solitude back into the particular quality of Earth's ceaseless connectivity. But before the return, there is still the transit, the return journey to Earth, another 7 months of interplanetary travel, during which the delay will shrink steadily from its post-conjunction levels back toward the brief, almost conversational delays of the launch period. The return transit is psychologically distinct from the outbound transit. The crew is heading home, which changes the emotional valence of the journey in obvious ways. But they are also, now, people who have been to Mars and back, people who carry the experience of the surface mission in their bodies and their memories and their understanding of who they are. During the return transit, mission psychologists observe something they call the review process, an informal but consistent pattern in which the crew, individually and collectively, begins to process and integrate the experience of the mission. The conversations in the crew's daily logs become more reflective. The tone shifts from operational to contemplative. The crew members begin to articulate in their messages home and in their private journals what the mission has meant to them, what Mars was like, not technically but phenomenologically, what it felt like to stand on the surface, to look at the horizon, to work in that thin, cold atmosphere, under that pale, distant sun, what it felt like to be in the blackout. These accounts are extraordinarily valuable, and not just as psychological data. They are valuable as human testimony, as the record of what it was actually like to be the first people to stand on another world and experience its particular form of solitude. They are the accounts that future crews will read, that mission planners will incorporate into their preparation programs, that historians will study as primary sources. They are the 38-minute story told from the inside by the people who lived it. And what they consistently describe, across the simulations, across the analog missions, across the extrapolations from long-duration isolation research that give us our best current approximation of what the real mission experience will be, is something that was not fully anticipated when the mission was first planned. Something that the engineers and the psychologists and the mission architects knew in theory, but that the crew members experience as a revelation. They describe the delay as a teacher, not a pleasant teacher, not a teacher they would have chosen, but a teacher nonetheless, one whose lessons were profound and whose classroom was unlike any other. The 38-minute window taught them patience. Not the performed patience of someone waiting for something they want, but the structural patience of someone who has accepted that certain things simply take time, that urgency cannot always be accommodated, that the universe does not reorganize itself around human impatience. They sent messages into the void and waited for responses, and used the waiting time for work. And over months this became not a frustration, but a rhythm. The rhythm of a life lived at the speed of light across the inner solar system. The delay taught them deliberateness. Every message was composed. Every communication was an act of intentional construction rather than spontaneous reaction. They chose their words because their words traveled a long way and arrived at a specific moment and could not be taken back. The enforced thoughtfulness of delayed communication produced over time a kind of communicative precision that they carry back with them, a habit of thinking before speaking, of considering what they actually want to say before they say it. That is one of the most consistently reported positive legacies of the Mars mission experience in simulation studies. The delay taught them about trust. Not abstract trust, but specific, earned, tested trust. Trust in their crewmates, trust in their own judgment, trust in the preparation that Mission Control had given them. The 38-minute window stripped away the safety net and revealed what remained underneath it, and what remained was enough. They were enough. The training was enough. The protocols were enough. The people they had chosen to go with them were enough. This knowledge, this tested, proven, non-hypothetical knowledge, is different in kind from the confidence that training produces. It is the confidence of someone who has been tested by reality and found adequate to the test. And the delay taught them something about Earth, about what it means to have a home planet, a single blue-white dot in a dark sky, and to be separated from it by a gap that light itself takes 19 minutes to cross. The experience of that separation, of the growing delay and the changing dot and the conjunction silence, produced in most crew members something that can only be described as a deepening of their relationship to Earth. Not a romanticization. They came back too clear-eyed and too experienced for simple romanticism, but a depth of appreciation, a specificity of love, that only absence and difficulty and the particular solitude of another world can produce. They know what Earth is in a way that people who have never left it cannot fully know. They know its fragility, how thin the atmosphere is, how narrow the habitable band, how precisely calibrated the conditions that make it suitable for the kind of life it hosts. They know its rarity, not abstractly as an astronomical fact, but personally, as the contrast between the warm blue world they came from and the cold red world they lived on for a year and a half. They know its beauty, not as an aesthetic observation, but as a physical memory held in their bodies of what it feels like to walk in open air under a thick sky with the sun warm on your face and the ground solid and familiar under your feet. They carry all of this home with them. And when they arrive, when the spacecraft slows into Earth orbit and begins its descent, when they feel gravity for the first time in 7 months and their bodies remember what weight is, when they emerge from the capsule and stand on the ground of the world they were born on, they bring Mars back with them, not as a souvenir, as a transformation. The question that the 38-minute window ultimately poses, the question that this entire story has been building toward through all the orbital mechanics and the medical scenarios and the psychological profiles and the conjunction blackouts, is not a technical question. It is a human one. And it is this: what does it mean to be the kind of species that does this? We are a species that evolved on a single planet, shaped by its gravity and its atmosphere and its specific quality of sunlight, connected to it by every biological and psychological mechanism we possess. We are a species whose social and emotional architecture was built for a world where the people you depend on are within shouting distance, where help, in a crisis, is seconds or minutes away, where the faces of the people you love are available to you in real time, where the planet beneath your feet is the same planet that has always been beneath your feet. And we are also, apparently, a species that will leave. That will build rockets and life support systems and interplanetary communication networks that will select and train and send human beings across 400 million kilometers of empty space, that will accept the 38-minute delay and the conjunction blackout and the re-entry shock and all the other costs of the crossing, and go anyway. Why? The answer that mission architects give is practical. Mars has resources, Mars has potential, Mars represents insurance against extinction-level events on Earth. Mars is the next step in the expansion of life beyond a single, fragile world. These answers are true. They are important. They are reasons to go. But they are not the reason to go. Not the deepest one. The deepest reason is something that appears in the testimony of the analog mission crews, in the journals of Antarctic winter rovers, in the letters of polar explorers and deep-sea researchers, and all the other people who have pushed into the edges of human habitability and come back changed. It is something that resists clean articulation, but that is unmistakable when you encounter it. It is the recognition that the limit is itself valuable. That going to the edge, going to the place where everything is difficult and the margin for error is thin, and the help is 38 minutes away, and the sky is the wrong color, and the gravity is wrong, and the home planet is a dot, reveals something about what you are, about what we are, about what life is capable of in its most improbable and tenacious forms. The first crew to land on Mars will carry with them everything that human beings have learned about how to stay alive in hostile environments, how to support each other under pressure, how to make good decisions with incomplete information, how to endure. They will carry the accumulated knowledge of every scientist who ever looked at Mars through a telescope, every engineer who ever designed a component of their habitat, every physician who ever thought about Martian medicine, every psychologist who ever studied human isolation. They will carry the love of everyone who ever looked up at the night sky and wondered, and they will carry the 38-minute gap, not as a problem to solve, but as a reality to inhabit, as the physical fact of how far they have come, as the measure, in the language of physics, of their distance from everything they have ever known. 19 minutes for a signal to travel from Mars to Earth. 19 minutes back. 38 minutes for a single exchange, 38 minutes during which they are in every operational and communicative and in some deep sense existential way alone on another world. This is what we are proposing to do. This is what the mission architects are designing for, what the psychologists are preparing people for, what the rocket engineers are building toward. Not an abstraction, a specific, calculable, inevitable reality that will be the daily lived experience of the first human beings to call another planet home. When the crew of the first crewed Mars mission sits down at their communications terminal on the Martian surface and sends a message home, when they record their voices or write their words or transmit their data across the void, they will know, with absolute precision, how long it will take to arrive. They will know the number. They will have watched it grow from 5 minutes to 10 to 20 to 38, have felt its weight increase with each day of the mission, have lived through the blackout when it became infinite, have watched it slowly shrink again as the planets turned. And they will send the message anyway, because that is what this is. Not a story about a delay, not a story about a communications engineering problem or a mission planning challenge or a psychological risk factor. A story about what human beings do when they reach the edge of what is possible and find that the edge is further than they thought. A story about a 38-minute window and the people who looked through it at a pale blue dot and called it home and kept working. The window will be open for as long as human beings travel between Earth and Mars. Every crew that makes the crossing will live inside it. Every crew will watch the delay grow, will experience the conjunction, will emerge from the blackout and re-enter contact with a planet that is always, from where they stand, 19 minutes in the past. They will adapt. They will endure. They will bring back what they learned in the silence, the patience, the deliberateness, the trust, the irreplaceable knowledge of what it costs and what it means to stand on a world that is not Earth and look up at a sky where Earth is a star. And then there will be more. More crews, more missions, more people for whom the 38-minute window is simply the condition of life on Mars, not a temporary hardship to be endured and left behind, but a permanent feature of existence on another world. As Mars is settled, if it is settled, the delay will become ordinary. The conjunction will become a planned operational period managed with the same matter-of-fact competence that Antarctic stations apply to their winter isolation. The children born on Mars, if children are ever born on Mars, will grow up understanding the delay the way Earth children grow up understanding time zones, as a feature of the world, as something that simply is. And somewhere on a Mars that exists in a future we cannot quite see from here, a person will sit at a communications terminal and compose a message to Earth. They will have grown up knowing the delay. They will never have experienced its absence. For them, the 38-minute window will not be a window at all. It will simply be the distance between worlds. But for the first crew, for the people who make the crossing before it is ordinary, before the protocols are settled and the infrastructure is established and the conjunction is just another item on the mission calendar, for them the window will be something else entirely. It will be the thing they carry, the measure of how far they went, the silence they passed through and came out the other side of, carrying whatever they found in the dark. 38 minutes, 19 minutes from Mars to Earth, 19 minutes back, the speed of light, crossing the inner solar system. And somewhere in that gap, travelling at 300,000 kilometers per second through the cold vacuum between two worlds, a human voice, saying something that matters, waiting to be heard.